Okay, move on to this side. Again, we're looking at growth and decay in the formulas. So reading the problem, it says the value of new car purchased for $24,000 decreases by 10%. So we've got some key pieces coming out. Then it says after how many years? Well, T is years, and it's asking me how many. So it's not telling me how many years this time. Will the car be worth half of its purchase price? So that half word right there is going to give us a key piece. It is decreases, not compound, so it's just going to be our decay function, decay formula. Okay, we know A. We know R, 10%, which is actually 0.1, 0.10 if you want. I don't know T, but I do know half has something to do with this problem. So that word half right there is talking about the final amount, which is Y. So Y is going to equal half of 24,000. So 24,000 dividing it by 2 gives me 12,000. My actual formula for this problem is 12,000, the Y, equals A, 24,000, times 1 minus 0.1 to the T. Now, that T is the variable, the thing we've got to find instead of Y, 0.1. Now we just got to solve just like we did on the previous problems. So I'm going to divide by 24,000 to get rid of it. I also think I'm going to calculate this right inside here. So over here, boop, 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 calculator says that 0.5 equals 1 minus 0.1. That's going to be 0.9 or 0.90. So this side is 0.9, and that's to the T power still. 0.9 to the T power. Now I'm going to switch sides because I don't like the exponent on the right side. So we've got 0.9 to the T power equals 0.5. Since the variable is up in the power, we're going to have to convert that to logs. Right, so I'm going to write log. Now my base is going to be the 0.9. And then these guys swap places. So up here is 0.5, and that equals T. Okay, boop, boop, boop. Calculator is going to tell us that is, make this 0.9 clearer. Getting picky. Calculator says T is about, looks like it is about 6.58. So I'm going to say it's 6.6 years. All right, 13 says you deposit 1,000 into an account. So 1,000, important number. 5% interest, important number. Compounded, ding, 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 ding. That means it's something, one of those A equals formulas. Then it says this word after. Now, if it said compounded continuously, that's the one with E. But since it says quarterly, we're going to use this formula. Okay, and then we're given all these pieces. Oh, there was one more number, that 3 right there. So I know my P is 1,000. R was 5%. Turning that into a decimal means it's 0.05. They told us T was 3. Then as far as N goes, because it said quarterly, that means N equals 4. So plugging it in, and get our value here. Capital A equals 1,000. 1 plus 0.05 over 4. And the power is 4 times 3. That's easy. Boop, boop, boop. Calculator said, looks like it's $1,160.75. Keyword compounded. Right, this one says you deposit 2,575 in an account that pays compound, keyword, monthly, keyword. Okay, 2,575 and a rate. How much would you have after 6 years? So it says compounded, and it says monthly. It does not say continuously. Remember, continuously is the key word of when you use that E formula. So we're using this one again. We've got our A, 2,575. We've got our R, which is 4.3%. Now you have to move that decimal 2 to the left, so that becomes 0.043. Time is 6. And then for N, we have to go back and look at that other number, right? So monthly, well, there's 12 months in a year, so N is going to be 12. Now we just plug it in. A equals 2,575. 1 plus 0.043 over 12. And then to the power of 12 times 6. Calculator says, I get approximately $3,331.39. Okay, now this part says describe the transformations from F to G, meaning I'm going to give you the function. You have to tell me what changes have been made. Now I put list here because I want you to remind yourself of all the different things that you could possibly do as far as transformations are concerned. You could shift left or right. You could also shift up or down. You can have a reflection over the y-axis. Or over the x-axis, most common. And then the third type we talked about was vertical stretches and shrinks. One of these we did talk about horizontal, but I'm not going to put horizontal on there. We're just going to stick with vertical shrink. So this point is where you'd pull out that cheat sheet, right? Cheat sheet, that one we just did. It can be used on any transformations. You just have to figure out where inside, right, horizontal and vertical are. So these guys right here, remember, are inside and inside. These guys are outside, outside. Oops. Let me point this the right way. Come on, bud. Man. That's actually, it won't move the right thing. Let's draw a new arrow. And then this one would be outside. And then this one will be outside also. So when looking at these log functions and the exponential functions, if you have an f of x equals some b to some power x, inside is up in the power. And then outside obviously is just out in front or at the end. So inside, that's the key one, is that it's got to happen up in that power. Now if you have a log function, so f of x equals log base whatever of x, this time your inside will be parentheses. like this right here. See now that one has all of a sudden a set of parentheses. And then outside is still out in front or at the end, right, if you add something, but that parentheses is your inside. That's the part that people struggle with the most, is recognizing where inside and outside are. All right, let's look at these then. Our cheat sheet. Here's the original. Looks like we've got this guy, and this guy. So if we've got a negative outside, that means it's a reflection, and it's outside, which means it's over the x-axis. Okay, this guy, the +3, that's inside, and it's adding, so it actually moved it left 3. Okay, now we're subtracting outside, which means it's going to move down 4. Okay, this log 1 starts out like that. Now it looks like this. We've got this 3 out in front. We've got an x minus 5. Now there's parentheses, right? Here was the x before. Here's the x now. So we've also got a transformation there. And then this minus 1 is new. So multiplying by 3 on the inside, or sorry, outside, that's going to be a vertical. Let's see, it's 3, which is more than 1, so we're going to stretch by 3. This one is inside, and it's subtract, so look at your little table. Subtract inside means we're moving right 5. This minus 1 is outside, it's on the side of the function, so it's actually going to be down 1. Okay, ln of x works the same way as log. This is your inside now. This is still outside, and this is still outside. So this time we're multiplying by a fraction. So that one's going to be a vertical shrink by 1/3. This one's inside, and we're adding, so that's going to be left 5. And this is outside adding, so it's up 1. Okay, here's the original. Here's the new one. We've got actually 2 things going on outside here, and then 1 thing going on up in the inside, right up in the power. So this negative out in front means there's a reflection over, looking at your table, out in front means the x-axis. This 2 is being multiplied outside, so it's going to be a vertical, let's see, 2 is big number, so stretch by 2, and then this is inside, and we're subtracting, so that means we've moved right 1. And that's it for part 1.